Hello, Matt. Welcome back to Math 110. We're going to cover lesson 2.4 today. We're going to talk about fractions and units, and let's get started. So the process of writing fractions in lowest terms is called reducing fractions. Here's one of our first skills. It's useful to do because it's easier to work with and interpret fractions when they're in lowest terms. For example, it's a lot easier to see that 5 halves is 2.5 than that 180 over 72 is equal to 2.5. So instead of carrying around all these numbers, it's also just easier to carry around just two numbers instead of 180. Well, I mean, still, but it's just larger, 180, 72. I have to write as 5 and 2. Okay. So how do we reduce fractions? Well, what I'm going to do is look for something that's the largest that divides out, and then I'm going to kind of add some thoughts to this. But if I take 4/6, I want to reduce it. This one's kind of easy because I see that 2 divides into 4, and it also divides into 6. So if I divide 4 by 2, I get my 2. 6 divided by 2 is my 3. And basically, I've rewritten the process is I've written 4 as 2 times 2. The 6 is 2 times 3. And then I've canceled out that 2 because 2 over 2 is just 1. So any of those common factors of multiples that are in the numerator and the denominator, I just cancel them out. So sometimes I can see what's the largest thing that I could cancel out, because here, when I'm canceling out that 6, I'm also canceling out inside that a 2 and a 3 at the same time. So if I know what the largest thing that divides out, I just go ahead and do it. 30 divided by 6 is 5. 12 is also divisible by 6. 12 divided by 6 is 2. So 6 times 5 is 30. 6 times 2 is 12. So those common 6s of multiples I cancel out. That's just 1. 6 divided by 6 is 1. Sometimes we want to do the opposite. I want to build up fractions, and the reason I want to build up, sometimes I just want to express them in the same denominator. So if I have two fractions and if I want to add them, the rule is they have to have the very same denominator. So in order to have the same denominator, I've got to do some transformation to get them into equivalent forms. So if I wanted to change this 5, if I needed to get it over with the denominator 20, well, I'm going to say, well, what do I need to multiply 5 by to give me 20, if I can? 20 divided by 5 is 4, so I'm going to multiply the 4 times the 5. That gives me 20, but I can't just arbitrarily go changing numbers in the bottom or the top. So what I'm going to do is multiply the bottom by 4, the top by 4, and this is equivalent 12 over 20. We work backwards, and if I was reducing, well, there's that common 4 here. I divide out with that one. I still get back the 3/5. So here's our negative 2/3. I want to write it as a fraction with the denominator 60. Well, what do I need to multiply 3 to give me 60? It's just the 60 divided by 3. That would be 20. 3 times 20 is 60, but I can't just do it to the bottom. Whenever I do to the bottom, I got to do to the top. So I multiply the top by 20. 2 times 20 is 40. And that negative sign, I still stick it around because I've got one negative. I'm not multiplying these by the negative. So multiplying fractions is actually easier than addition or subtraction of fractions. To multiply two fractions, all I need to do is multiply the numerators and then multiply the denominators of those two fractions. So if I'm multiplying 2/3 times 7/11, I'm going to multiply the top. 2 times 7 is 14. Then I'm going to multiply the bottom. 3 times 11 is 33. And that gives me the product of those. Here I'm multiplying 5 halves and 12/7. My result, 5 times 12 is 60. 2 times 7 is 14. And if I reduce this down, well, that looks like it's divisible by 2. 60 divided by 2 is 30. Divide that down by 2 gives me the 7. If one of the factors isn't a fraction, you can make it a fraction just by giving the denominator 1. So this is just saying I've got a whole number. And a whole number can be written as a fraction is by being that over 1. 100 over 1 is 100. So I've just turned it into an equivalent form where it's the same thing. So then I'm multiplying. Once I do that, the top is multiplied. 100 times 3 by 300. 1 times 5 is 5. And then that keeps everything what I'm supposed to do. Should I multiply the 100 times the 5? Should I multiply the 100 times the 3? It's over 1, so the 1 gets multiplied to 5. 100 times 3, and the product of that would be 60. And if I have multiple fractions that I am operating on that I need to multiply together, the same rules apply. I'm just going to multiply all the tops and all the bottoms. So 6 times 1 times 2 times 4 gives me the 48. And 1 times 3 times 1 times 1 gives me the 3. And then 48 divided by 3 is 16. Now, frequently, when I'm working on this, I want to reduce them down halfway through. So here's some things that I can see. Well, I see that this 6 will go into 3 directly, right? So this is really 3 times 2 if I write it into its prime factors. Prime numbers is numbers that can't be divided by any other number except 1. They excel from 1. So this is 2 times 3. So I'm going to cancel out that 3. And all I'm left with is 2 times 2 is 4. 4 times 4 is 16. And I don't have to do all this multiplication and do division. So anytime I can cancel across multiplications, I will. Here's the very same thing. And I can do this with variables. Variables are just, temporary holding places so that I can do operations on a number that I'm not currently aware of what it is. Hopefully we're either going to find out what the number is later. Somebody's going to say, hey, what's the result if y is equal to 2? Or I could say if I've got some equations that I can work on, I may be able to work backwards and find out what that value is. So here I just want to simplify this little piece of it. This is a multiplication y times 3 minus y over y. Here's the very same thing. I want to cancel out these common factors, their multiplications, and I'm just left with the 3 minus y. If I've got 12t divided by t squared, this is t times t, so one of those t's are going to cancel. T over t is just 1. 12 divided by t. So in many problems that we're going to be working with on Math 110, we're going to need to change from units, different unit measurements. And what we want to do is be able to recognize unit equivalences. If we can recognize unit equivalences, then we can build up a conversion factor, something that we multiply by that changes it from one unit to another. So here is an equivalence. 12 inches is the same thing as 1 foot. It is the very same length. It's just in different measurement units. So here's the unit equivalent, 12 inches, 1 foot. And it's just a statement that says the two measurements in different units represent the same size. So the following table, I'm going to give you this, and you'll be getting one of these on the test as we go forward as needed. And the goal is certainly not to memorize the equivalences. It would be helpful if you had these things, but you should know how to use them if not memorized. So here are my equivalences. If I'm linked, here's the English system. These are the English systems. 12 inches is 1 foot. 3 feet is 1 yard. 5,280 feet is 1 mile. So this is equivalent. 16 ounces is a pound. 2,000 pounds is a ton. And then here's our liquid volume equivalents. 3 teaspoons gives us a tablespoon. 8 fluid ounces is a cup. 2 cups to a pint. 2 pints are the same thing as 1 quart. 4 quarts are 1 gallon. A cubic centimeter. A centimeter cubed, and this is sometimes also written as a cc. You hear expressions often given 3 cc's. That's 3 cubic centimeters. And that's the same thing as 1 milliliter. So if you would have been 3 milliliters or 3 cc's. Time, we recognize 60 seconds as a minute, 60 minutes as an hour, 24 hours as a day, 7 days a week, 52 weeks in a year, and then 365 days as the 1 year. We will also be using the metric system, and here is 3 different things for the length. The base unit is the meter, the weight is grams, and volume that we'll work with is the liter. We still use in seconds for time, but here they use these prefixes to indicate either 1,000, 100, 10 times something, a tenth, 100, a thousandth. And what this basically says that if you want to go from one of these units to this unit to convert, you need to move the decimal going from here to here to the right. So 3 kilometers would be 3,000 meters. 4,000 or 30,000 decimeters, 300,000 centimeters, and 3 million milliliters. We move from this side here, move the decimal place to the left. So I got 1 millimeter, 0.1 centimeters, 0.01 decimeters, and then we continue on. So I can also convert between systems. So I can go from the SI over to the English system. 2.54 centimeters is 1 inch. 1 meter is approximately equal to 3.28 feet, but I can use those as a conversion factor, unit equivalent. 1.61 kilometers is approximately equal to 1 mile. 28.3 grams per ounce, 2.2 pounds is approximately equal to 1 kilogram. 1.06 quarts is approximately equal to 1 liter. 3.79 liters is approximately equal to 1 gallon. And our temperature scales are from Fahrenheit to Celsius or centigrade. If we knew what it was in Celsius, we would multiply that times 9/5, add 32 to it, and that would give us the temperature in Fahrenheit. And then working the other way from the Fahrenheit, I go over. Here was a common one. What happens if F is 32 degrees? 32 degrees minus 32 is 0, C is 0. Here, if C was 0, what do I get? F is 32. So another scale is the Kelvin scale, and that's basically looks like the centigrade scale, the Celsius scale, except that the Kelvin scale is down. So if I had 273.15 degrees in Kelvin, that's the same thing as 0 degrees in centigrade. If I had 0, I get back to 273.15. So you hear frequently of absolute 0, this is when the K is 0, minus 273.15 degrees Celsius. So here's some prep skills. We can work these in class. Try to go through these things, write down some questions that you have, simplify each fractional expression by dividing out common factors. We could divide out those B's. There's some X's we could get to divide out. So we would go through, we would like to basically work on conversion factors. Conversion factors is just built from that equivalence, that unit equivalence. So let's just basically go through. Let's say if I went and did that conversion unit equivalence, I saw 1 kilogram is equal to 2.2 pounds. I can write this as if I divide both of these things, both sides, by that same number. So 1 kilogram is equal to 2.2 pounds divided by 2.2. This is basically 1. These are the very same numbers. They're just in different units. So that is 1, and I can multiply anything by. So if I wanted to convert 2 pounds, I'd have 2 pounds times this one. The pounds would cancel, and I would have 2 kilograms divided by 2.2. That would be in kilograms. If I'm going from kilograms to pounds, I want the one with the kilograms on the bottom, and then we just multiply that, and it would work out. Okay, so we'll do some of those in our lab as far as, and a couple of them coming up. Okay. So here is, let's do a conversion factor based on the fact that 1 liter is equal to 1,000 milliliters. So either one I can put on top as needed. So here, if I want the liter on top, the 1,000 milliliters on the bottom, so this would be, I'm going from milliliters to liters, whichever one I want to go to is on top. And if I wanted to go from liters to milliliters, I want the milliliters on top, 1,000 divided by 1 liter. This is the very same thing. So these are unit equivalences. Okay. So this is how I would use them. Here, if I wanted to go to, I wanted to convert 450 milliliters out to liters. And the question is, which one do I use? So if I did this one, if I multiply 450 milliliters, remember I can write this over 1, times that unit equivalence, that conversion factor, here the milliliters would cancel. So those units are gone, and now it's just pure numbers. 450 times 1 is 450, divided by 1,000, and the answer is in liters. What if I had done it the other way? 450 milliliters times this other one, which is the very same, it's just a different conversioning from to. Here I would have 450 times 1,000, I would have milliliters squared per liter, and that just really doesn't make sense of what we would need. So I wouldn't use this one. We would want to go with this one over here. Okay, the first one is what we do because the milliliter units cancel and the L remains. I'm always looking about what unit I want to go from and which one I want to go to. The one I'm going to needs to be on top if I'm just talking simple conversions like this. Here's where they were saying if I multiply it the other way, I'd get a milliliter squared per liter, and that really has no meaning as far as what we are needing. Okay. Here's the very same thing. If I'm going from gallons to liters, 1 gallon is 3.79 liters, or 3.79 liters per gallon. That per. So if I want to go from the 0.45 liters from the previous one, if I wanted to convert it into gallons, I want the gallons on top because I want to go to gallons. The liters need to cancel from the top and the bottom, and then it's just 0.45 divided by 3.79. That's the 0.12 gallons. So doing the whole thing out, we can string these things together. So if you're going to do any calculus, if you're going to do any chemistry or biology, this is frequently encountered, and that you just kind of string these things together. I want to go to gallons, but I have these intermediate conversions. Milliliters, I want to first go to liters, so I'm going to cancel out liters, and then I want the liters to cancel out to give me the gallons. I really want the result in gallons, but I don't have any straightforward conversion that goes from milliliters, gallons from the milliliters, and that's why I need this intermediate one. Here's one that we could string out together, and that you should see a little bit better. My house is just about 15 miles from the Gulf of Mexico to the Florida coast, not me personally. How far is this in inches? Use 2 conversion factors in one calculation, just like we did the previous one. So I'm kind of work backwards, and then I'm going to kind of go a squeeze clay. I want my answer in inches, so I go through and I look about which one is my only equivalence that I can build a conversion factor. And the only one in the chart was 1 foot is equal to 12 inches. 12 inches is equal to 1 foot. I want that. That's my final answer, so I know I've got to have this one, let's say at that furthest right, to leave me with inches. I'm starting with 15 miles, and what intermediate calculations can I find? And I may have to go down through several. But here's the foot that gives me a common here. 1 mile, 55,280 feet. That miles would cancel, so it would just be the 15 times the 5280. Feet would cancel, and all of this would be in terms of just that final unit that's left, the inches. So here's that metric system. Let's kind of take a look at this thing. Again, moving decimals to the right and to the left. So when we converted 450 milliliters to liters, we did the dimensional analysis, we did conversion factors, But the nice thing about the metric system is that we can basically go with these prefixes back and forth to find. So if I go milliliters to liters, I want to move over 3 to the left. So if we go back to that chart, I'm at milliliters, I want to go to liters, I want to go 1, 2, 3 to the left. 1, 2, 3, and that gives us 0.450 liters. If I wanted to go the other way, 0.450 liters to milliliters, I would go 1, 2, 3 back to the right. So convert 0.44 liters of love potions into DL and KL. That's deciliters, and then kiloliters. So if I'm going 0.44 to the right, I move the decimal place to the right, 4.4 deciliters. And here I wanted to go to the left, so I'm going to move decimal to the left. Okay, so here, if I went to here, I went to deciliters, and now I'm going to go from 0.44 out to kiloliters, so I'm going to go 1, 2, 3. How many? From here, 1, 2, 3. Both of them I'm starting at the 0.44, so I get the 0.00044. And it's asking you which one would be more reasonable to carry around. This is a more compact form, 4.4 deciliters, instead of the 0.00044 kiloliters. It's just easy to go back and find that one with the decimal place between the two leading numbers. Here's this potion that comes in 0.75 gallon containers. Convert this to cubic centimeters, cm cubed, centimeters cubed, or cc's. That's the very same thing, the cm cubed or the cc's. So here's ones that we've got: gallons to liters, and then milliliters to liters, and a milliliter is the same thing as a cc, or 1 centimeter cubed. Okay. I wanted the result in cc's, so this needs to be at top to milliliters, and then I start working backwards. 1,000 milliliters per liter, 3.79 liters per gallon, and then that gets rid of that gallon, that cancels out. So here's the cm cubed, or cm times cm times cm. So that gives you the cm cubed. That was that cc. The cc is more in terms of a liquid volume, is why the milliliters are the cc. That's kind of but it's also just a cubic centimeter. That's the very same thing as a cubic centimeter. But this is the one that we would use for volume if it was a hard volume, and the cc is more in terms of what you would do as a liquid volume. So let's say if I wanted to go to cubic inches, I want to go, this doesn't tell you what we're doing very well, but I want to convert something from a cubic centimeters over to inches to cubic inches. And how can I do it with just those equivalents? That nothing is the changing of the volumes, but I can build this thing up. If I have 1,000 cubic centimeters, and if I wanted to convert it over to cubic inches, each one of those centimeters, I can do a single conversion factor. 1 inch is 2.5 centimeters. That gets rid of one of these. Got two more. 1 inch over 2.5 centimeters. That cancels out a 2. 1 inch over 2.54 centimeters. That cancels out the third. So it's just 1,000 divided by 2.54 cubed. And the only answer I'm left with is inch, inch, inch is inch cubed. That's kind of what we wanted into this, even though it wasn't very clear. Question 10. It says if this was just cubic centimeters, the 2842.5, how could I go over 2 inches cubed? We're going to do the very same thing. This is cm, 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 so I need 3 of those conversion factors, and I'm ending up with inch times inch times inch is the inch cubed. So based on what you just did, fill in the blank to create a shortcut to convert between cubic centimeters and cubic inches. So if we did this, if I said this many is equal to this divided by that would be the 16.39 cubic centimeters is equal to 1 inch cubed, or 1 inch cubed is equal to the 2.5, 2.5, 2.5 centimeter cubed. Okay, so that basically finishes it up. Here's just some different ones. If I'm going from an area, here's the same thing. I'm going from a feet square, I want it to square inches. I've got 2 feet, so I need to go I want to get inch squared area. I'm going to divide it by the feet, give me rid of one of them, feet, give me rid of that second feet, and that converts them back over to inches squared. Okay. So we can do both of these in area and volume to conversion factors back and forth. And we'll do those in some problems this semester. So I hope you found this helpful. I'll see you next time. Have a good day.